Here's how to create an AI with 5 lines of code. The AI can predict whether an email is spam, a mushroom is poisonous, and so on. As an example, let's say we want to predict whether someone with chest pain has heart disease. When patients show up with chest pain, it often isn't obvious to doctors whether they have heart disease. Here's some real-world data on 900 patients and their features: their age, sex, type of chest pain, blood pressure, and so on. I downloaded it from this website, Kaggle.com. The website describes what the columns mean. For example, chest pain is classified into 4 categories. Each category has its own abbreviation. Each row represents a patient, and each column represents a feature. In column L, 1 means that a particular patient had heart disease, and 0 means that they didn't. Here's our task. Train an AI that predicts whether a patient has heart disease using information in all the other columns. I'll use part of the data to train my model, and I'll use the other part to see whether my trained model can make accurate predictions. Now let me select all the data. I'll click on Randomize Range so that Google Sheets randomly sorts the rows. Nicely done, Google Sheets. Now let's move the bottom rows to another sheet. I'll rename the sheets Training and Testing. And now I'll download both sheets as separate files. Let's go to my favorite website to type Python code, colab.research.google.com. I'll click on New Notebook. The first line of code is pip install AutoGluon. Then I'll press play, which executes the command. What does the command mean? The 3 words say, "Hey Python installer, please install AutoGluon for me." AutoGluon is a library of AI tools. It might take a couple of minutes, so I'll watch a cat video in the meantime. Now, I'll add in a new code cell by pressing the code button near the top. I'll paste and execute my second line of code. From AutoGluon.tabular import tabular dataset, tabular predictor. This tells Python to import 2 tools from AutoGluon: tabular dataset and tabular predictor. Tabular means table format. Think of an Excel sheet or a CSV file. Now, I'll upload data by clicking on the folder button and then clicking upload. The files appear here, so I'll close the window. Next, add in a new code cell and type these 3 lines in. The first line means, "Hey Python, look at the file heart-training.csv and transform it into a tabular dataset. Store it in your memory as training_data. The next line creates the AI model and tells the AI model to predict the column heart disease. All the other columns will be used to predict heart disease. The last line trains the AI model. It uses the training data object created in the first line. When training, Python tries many AI models before settling on the best one. The code has finished running and you've trained your first AI model. Everything is stored in memory under the name train_predictor. How can I use the model? I'll have the model make predictions on data it hasn't seen before. The first line stores the testing dataset in memory as test_data. What about the second line? It predicts whether each patient in the test data has heart disease. The trained AI model saves the predictions in memory as predictions. You can print out the predictions by typing print predictions. The first observation is a 1, which means that the first patient in the dataset is predicted to have heart disease. The second patient is also predicted to have heart disease, but the third patient is predicted not to have heart disease, and so on. If you want to save the predictions, type in these 2 lines of code. The first line imports a tool to create a CSV file. The second line saves the predictions as a CSV file. The file will appear in the File section. You can double click on it to preview it. It's also easy to download it. You can then add the predictions as a new column in the testing.csv file. You can even see how confident a model is about any prediction. Just add in these 2 lines of code. I see numbers that range from 0 to 1. High numbers in the first column mean that the model confidently predicts it's a 0. High numbers in the second column means the model is confidently predicting that it's a 1. For example, the model is relatively confident that the first patient has heart disease. But how good is the model? Let's find out with 4 lines of code. The first 2 lines create something called a confusion matrix. The next 2 lines display the matrix, which you can see here. A confusion matrix tells you how often the AI model predicts a 0 when the actual value is 1. That is, how often does a model predict a heart disease patient doesn't have heart disease? And vice versa. 4 patients had a predicted label of 0 and an actual label of 1. That is, they were mistakenly told that they didn't have heart disease. We call this false negatives. 13 patients had a predicted label of 1 and an actual label of 0. That is, they were mistakenly told that they had heart disease. We call these false positives. We also have 56 true positives and 47 true negatives. Here's 3 ways to measure a model's performance. First, what percentage of predictions are correct? We simply sum the number of true positives and true negatives and divide it by the sum of all 4 cells. Second, of those with heart disease, how many were predicted to have heart disease? The AI term for this is recall. In this case, recall is 56 divided by the sum of 56 and 4, which is 56 divided by 60. Finally, how often are positive predictions of heart disease correct? The AI term for this is precision. We calculate this by seeing how many positive predictions were true positives. In this case, precision is 56 divided by the sum of 56 and 13, which is 56 divided by 69. The importance of recall and precision depend on the context. If false negatives are costly, you should try to have a high recall. I think that false negatives are costly in this context, as missing heart disease can be fatal. If false positives are costly, you should try to have high precision. You can boost performance by getting more predictors. For example, whether a patient has a family history of heart disease. You can also gather data on more patients. That said, this model's performance is a good starting point to my untrained eye, especially since the model didn't go to medical school. It could also automatically handle both text data and numbers. So why not try building a model on your own? You can go to kaggle.com to download a dataset. When training your model, you only need to change a couple of things. First, the file names of both your training and testing data. Second, the name of the column that you're trying to predict. If the column you're trying to predict is spam, then replace this with spam. But before using your model, make sure you understand the limitations of both the model and the data. For example, what data was included in the sample? Let's say you train a spam predictor on emails from the year 2000. The spam predictor may perform well on emails from that year, but is unlikely to perform well today. After all, spammers come up with new tricks every day. Also, what does each feature in the dataset mean? Were they measured accurately? And so on. And test your model with as much data as possible. Are focused on binary outcomes. A patient either has heart disease or doesn't. An email is either spam or not spam. What if there's more than 2 outcomes? Let's say you're building an AI system to recognize digits from images. Then there's 10 outcomes. Here's some code I wrote to recognize digits. I still use the same code and calculated the AI's performance in the same way. I just changed the things I mentioned earlier. 1, 2, and 3. Because the code takes some time to run, I ran it beforehand. Let's look at the results. The predictions range from 0 to 9 because you're predicting what digit an image is. There are now 10 columns for predicted probabilities. In this case, the model is confident in predicting that the first image is the digit 7 because it has by far the highest number. The confusion matrix now has 10 rows and 10 columns. You can now calculate precision and recall for each digit. For example, let's calculate recall for the digit 0. 980 samples are 0 because the sum of the first row is 980. Of the 980 zeros, 963 were predicted to be 0. So the recall for the digit 0 is 963 divided by 980, which is 98.2%. So the computer correctly identifies 98% of zeros. Wow! What if you're trying to predict a continuous outcome, like house prices? Here's an AI model that was trained to predict California house prices. The code to make predictions is still the same. However, model performance is measured differently. In this case, I use the mean absolute error, or MAE. These 2 lines of code calculate the MAE. That's the average absolute difference between your prediction and the actual outcome. The MAE is 1.3 million. The average house price in the test set is 2.3 million. On average, our predictions are off by more than half of the average house price. I would examine why the error is so big. Is there enough data? What predictors do we have? And so on. In this case, we only have data on 500 houses. We also don't know a lot about a house's location. So there could be multiple issues. We've learned how to train an AI with 5 lines of code. Here's the cheat sheet. And we've learned some basic methods to evaluate its performance, both for continuous outcomes and for discrete outcomes. If you didn't know any Python, knowing the basics will help you understand this video even better. Check out my video. Write your first computer program in 10 minutes. Cheers to a wonderful journey with AI.